solve x to the power of 2/3 is equal to 2x to the power of 1/3 plus 3. It looks like the equation that we can solve by substitution method. Let's go ahead and move everything to one side of the equation, get into standard form. If I subtract 2x to the power of 1/3 and 3 from both sides of the equation, I would get x to the power of 2/3. Then this becomes minus 2 times x to the power of 1/3 minus 3 is equal to 0. Okay, so I'm going to let x to the power of 1/3 equal to any variables I like. So let's call it w this time, w. So if I square both sides, if I square the left-hand side, the right-hand side, let's be square and cubed. Square. So on the left-hand side, I get x to the power of 2/3 is equal to w squared. So that's exactly what we have here. See how this is x to the power of 2/3, x to the power of 1/3. So when you realize that these two terms are square of one another, you can use this method. So I'm going to go back and let w squared equal to x to the power of 2/3, like I have here, minus 2 times w, because we said w is equal to x to the power of 1/3. Now I can solve this easily by factoring. Those of you who are following me live, is this factorable?
Yes.
Okay, so like the w here and w here. What are you going to select for 3? Maybe 1 and 3? 1 and 3. Very good. So this would be w. This would be 3w. Can I make negative 2w out of that? Because I mean negative 2w, right? Well, it would be negative 3 and positive 1. So very good. So it would be negative 3 and positive. So that would make this positive, that's negative. So here, how you factor, make sure you check the last two terms. Plus 1 and minus 3 must be a product of this term here, which is negative 3, which we do have that. So we get w plus 1 is equal to 0. So w would be equal to negative 1. That's one solution. Or w minus 3 is equal to 0. So w is equal to 3. That's another solution. Again, we're not solving for w, we're solving for x. We go back to our original assumption. We said that w is equal to x to the power of 1/3. And we found two values here for w. So we said w is equal to minus 1. W is equal to 3. So let's find x. So in this case, minus 1 must be equal to x to the power of 1/3. 3 must be equal to x to the power of 1/3. Again, those of you who are watching this live, how do I eliminate this 1/3? What do I have to do? Raise this side and this side to the power of what? Not negative 1. This is 1/3. You want to make it 1. What's that? Just 3 over 1, or 3. If I raise this side to the power of 3 over 1, because 1/3 times 3 over 1 would be equal to 1, right? We want to make this equal to 1. So if I raise both sides of the equation to the power of 3, then I can do that, right? If I raise this side to the power of 3, this side to the power of 3, I can do that. Because here I have minus 1. Here I have x to 1/3 times 3 over 1 would be 1. So it would be x is equal to, what is negative 1 to the power of 3? Negative 1. Do the same thing with the other side. If I raise the left-hand side to the power of 3 and right-hand side to the power of 3, so what do I get for x? 3 to the power of 3, which is 27. So x equal to 27. x equal to -1. Once again, every time you find these two terms are square of one another, you can use this method. You can let the smaller one be equal to some variable like w. If you raise them to the power of 2, then you get the other one. So by doing this, you're forcing this to be a second order equation, and once you solve for this variable, you can go back and solve for, in this case, the variable that you were looking for originally.